यस, गुड मॉर्निंग स्टूडेंट्स। देखिए, हम लास्ट बात कर रहे थे एंगल ऑफ रिपोज के बारे में और हमने देख लिया था कि एंगल ऑफ रिपोज क्या होता है कि इट इज द मिनिमम एंगल सो दैट द ब्लॉक रिमेन स्टेशनरी ऑन एन इंक्लाइन प्लेन। और एंगल ऑफ रिपोज की वैल्यू हमारे लिए क्या आ गई थी कि tan थीटा इज इक्वल टू म्यू, तो कॉरस्पॉन्डिंग थीटा इज कॉल्ड द एंगल ऑफ रिपोज। देखिए प्रॉब्लम्स देखेंगे इससे रिलेटेड। देखेंगे यस, अ ब्लॉक ऑफ मास 1 kg is placed on an inclined plane connected with string. As shown. If coefficient of friction static friction is mu s is, let's suppose, 3/4. Calculate tension in a string. स्ट्रिंग में टेंशन कैलकुलेट करिए। देखिए ये हमारे पास इसका डायग्राम है क्वेश्चन का। दिस इज द ब्लॉक ऑफ मास 1 kg. It is connected to it and here mu s is 3/4 and this angle is 37. We have to calculate what? We have to calculate tension in a string, and if coefficient of static friction is this, then calculate tension in a string. देखो मैं क्या कर सकता हूं इसमें। सबसे पहले हमें ये चेक कर लेना चाहिए कि जो ये एंगल है, मतलब इट हैज अ टेंडेंसी टू मूव और नॉट। दिस एंगल इज ग्रेटर देन द वैल्यू ऑफ एंगल ऑफ रिपोज और लेस देन। तो इफ वी चेक इट, व्हाट इज द एंगल ऑफ रिपोज? वी नो tan थीटा इज, दैट इज एंगल ऑफ रिपोज। You just take this angle as 45. इस एंगल को 45 ले लो। अगर एंगल ऑफ रिपोज थीटा है, देखो मैं क्या लिख सकता हूं, आई कैन राइट tan थीटा इज इक्वल टू म्यू एस। नाउ व्हाट इज tan थीटा? इट इज tan 45। नो, tan थीटा इज इक्वल टू म्यू एस। थीटा नोट ले लो। तो व्हाट इज दिस? इट इज 3/4. So this angle is how much? Theta naught is, from there what is theta naught? The angle of repose is 3/4, that is 37 degree. Now if it is 37, here block या एंगल ऑफ इंक्लिनेशन here angle of inclination is greater than angle of repose. So block has a tendency to move. तो मैं क्या कह सकता हूं, अगर इसकी टेंडेंसी है एंड देन आई विल मेक अ फ्री बॉडी डायग्राम, आई कैन शो which forces are acting on it, that is mg cos 45 is acting downward, that is mg by root 2, mg sin 45 and this is cos, this is also mg by root 2, and here it is normal reaction is acting. Rather than that, tension is acting, or here it is maximum static friction because still it is at rest. So we can say what? If it is at rest, so we can say directly that Fs max is mu s max into Fn. What is mu s max? That is 3 by 4. What is Fn? mg by root 2. If I will solve it, so we will get mg by root 2 that is equal to T plus Fs max, that is 3 by 4 mg by root 2. So what is tension in the string? T is mg by root 2 minus this is 1 by 4 mg by root 2. This is 1 by 4 mg by root 2. That is the tension in the string. Is it clear? So we can say like this. Yeah, we can solve like this. Next. देखो next is a block of mass capital M is equal to 10 kg is connected with mass small m with a string passing over pulley. As shown. If friction coefficient between capital M and inclined surface that is mu s max is 0.6 and mu k is 0.5. Then calculate minimum and maximum value small m to keep capital M at rest. This is the figure for it. Capital M and small m, and it is a rough surface having mu s is 0.6 and mu k is 0.5 and its mass is 10 kg. This angle is 37 degree. So we have to calculate the minimum and maximum value of the small m so that the block capital M remains at rest. देखो होगा क्या, दो केसेस बनेंगे इसके इसमें. If small m is small, come on. So it has a tendency to move in this direction, whether it is at rest. It has a tendency to move in this direction. Here it is acting mg sine 37. So it is mg 10 into g sine 37. Sine 37 is 3 by 5. So it will become how much? 6g. That is 10g into sine 37 is 3 by 5. That will come out to be 6g. This is acting as tension. It has a tendency to move in downward direction, so the friction will act in upward direction for the case 1. Similarly, tension is acting in this direction. Small mg is acting downward. Now, we can say it is at rest. At rest. And we know that mg cos 37, that is 4 by 5 mg. That is 10g into 4 by 5. That will come out to be 8g. Is acting in this direction, normally action is acting in upward direction. Right? So at rest I can say directly कि first is Fn is equal to what? 8g. उसके बाद मैं क्या लिख सकता हूँ? It is also at rest. So I can say कि T plus F. What is F? It is at rest. F is 0.6 into Fn. Fn is 8g. It is equal to 6g. So T is come out to be 4.8g, 6g. That is come out to be 1.2g. Right? And if it is 1.2g, so what is the value of small m for that? Now small mg is equal to what? T at rest. So we can say कि small m into g, that is 1.2g. So what is the minimum value to keep at rest? That is 1.2 kg. Right? Next is case 2. If m is large. अगर m बड़ा हो तो क्या होगा देखो. Now if it has m बड़ा है तो it has a tendency to move in downward direction. The friction upward direction, friction act in downward direction. So what is the case for that? In that case, Fn is still remain 8g. But if you observe at this direction, that is along the plane, so you can say friction is downward, 6g is downward, tension is upward. So T is equal to 6g plus friction. And what is friction? Friction is again mu into Fn. Stress पे tendency है चलने की. 0.6 into Fn. Fn is 8g. Right? So it will become how much? That is 10.8g. Right? If tension is upward, so here also T is equal to what? Small m into g. G से g cancel. So what is small m? 10.8 kilogram. right? So the maximum value of the m, so that it will remain at rest, so it will be this, and it will remain at rest, it will be this. So it will lies between the 1.2g to 10.8g. So when m is lies between this, so it will still remain at rest for the range. Is it clear? So for this range of values, it will always remain at rest. Here's again next question. A block of mass 5 kg is placed on an inclined surface of angle of inclination 53 degree. If friction between block and surface is 0.4, the 0.3. 0.3, calculate minimum and maximum value of external force capital F applied along incline to keep it at rest. This is the thing. ये ब्लॉक है 5 kg का, and the friction coefficient, it is a static friction coefficient, 0.3, and a force is applied parallel to it to keep it at rest. So we have to say calculate the minimum and maximum value of the force so that it will remain at rest. देखो मैं क्या कह सकता हूँ. First of all, this block is placed on it. It's what is the force is acting on it? That is 5g sin 53. Sin 53 is 4 by 5, so it will come out to be 4g. And this is an mg, that is 5g cos 53. Cos 53 is 3 by 5, so it is 3g. And this is what? Fn. Now, when we apply this force, first of all, if F applied is small, so there are two cases in it. Applied force is small. कम लगाओगे अगर आप, तो ब्लॉक हैव अ टेंडेंसी टू मूव इन डाउनवर्ड डायरेक्शन. इसकी मूव करने की टेंडेंसी है नीचे की तरफ, तो इसके ऊपर 4g नीचे रहेगा, F ऊपर लेगा. अगर इसकी टेंडेंसी नीचे जाने की है तो फ्रिक्शन विल एक्ट इन अपवर्ड डायरेक्शन. एंड इफ F इज लार्ज, five kg is placed on it. Four G is acting downward still, and F is acting upward. If F is large, then it has a tendency to move in upward direction, so the friction will act in downward direction. So the friction will act in downward direction for it, right? Now, you can easily judge what is the value of friction. It will at rest. So what is friction? Mu into Fn. Fn is equal to 3g. So mu is 0.3. So 0.3 into 3g. 30 into 0.3, 9. Right? Now, if it is at rest, here we can write 4g is equal to F plus small f. So what is the value of F? 40 minus 9, 31. Here it is at rest. We can say easily 4g is acting downward, F is acting downward. So we can say F is equal to 4g plus small f. And what is small f? Small f is mu into Fn. That is 0.3 into 3g. 9 Newton. It will leave 49. So the maximum and minimum value of the force applied is, that is in between the 31 Newton and 49 Newton, so that it will remain at rest, right? So this is a pattern. देखो, I am discussing one more question related to the chain. A chain of mass, a uniform chain. A uniform chain of mass capital M and length capital L is lying on a rough surface. On a rough table of friction coefficient mu. If 1 by nth part of chain is hanging and is at rest, then calculate friction coefficient is mu and 1 by nth part of the chain is hanging. Friction force acting on it. This is the thing. Total is L and this is 1 by nth part. The length is L by n and this length is L minus L by n, L into 1 by n minus. Right? Friction coefficient here is mu. The friction coefficient here is mu. Right? You can take if you want. Now we have to calculate the value of what? We have to calculate the value if it is at rest, the value of the friction. देखो मैं क्या कर सकता हूँ? If we make the free body diagram of this, यहाँ पर एक टेंशन लग रही होगी T. Same tension is acting in this direction T. अगर नीचे वाली इस चेन का मास m1 है, मान लो अगर इस चेन का मास m1 है तो आई कैन से द फोर्स एक्टिंग इज m1g. इसका मास m2 है तो इसके नीचे लगेगी m2g. नॉर्मल एक्शन लग रहा होगा Fn. T से आगे खींचने जाते हैं तो फ्रिक्शन कहाँ लग रहा होगा? पीछे की तरफ. हाउ मच इज द फ्रिक्शन एक्टिंग? इट इज स्मॉल f. राइट? तो मैं क्या लिख सकता हूं सॉल्यूशन में? एट रेस्ट m1g is equal to T and T is equal to what? Friction coefficient. मान लो मैं F लिखता हूँ, friction I am leaving, it is F. So we can say easily, you just consider, we have to calculate the value of mu. Friction coefficient मैं हटा रहा हूँ on a rough table. Friction coefficient acting for corresponding friction force. What is F? Mu into Fn. Right? So what is we can say? Now what is M1G? Mass. It is the mass of the L by N length. Into G. Right? What is M2G? Length is L into 1 minus 1 by N. Into G. So what is mu into Fn? Fn is M2G. So we can directly say from there, okay, what is mu? M1 by M2. If it is M1 by M2, take the ratio of it. That is M1G by. Take the ratio of it, it will come out to be capital M and capital M will cancel out. G and G will cancel out. That will be 1 by N. 1 minus 1 by N. That will come out to what? 1 divided by N minus 1. This is the value of refractive index. The value of refractive index for which it is remains at rest. Right? Clear है सबको? Next. Yes, next. Now we will discuss about blocks placed over one another. And we are taking the case when friction is present between blocks. This is I am starting from an example. This is a block of, let's suppose, the 5 kg, and it is a block of 3 kg. There is a block of 5 kg and another is a block of 3 kg, and external force is applied. This surface is rough. Now the question is that कि whether the blocks will move together or it will move alone. मतलब अलग अलग चलेंगे और whether both will move together. That is a question to be raised. देखो उसको मैं कैसे चेक करेंगे. आप पहली बात ये सोच के चलो कि इकट्ठे कब चलेंगे. If blocks will move together, then static friction acts between them. Then static friction acts between them. So, for an applied force, both moves together till maximum static friction acts between them. मतलब बहुत तब तक चलेंगे जब तक उनके बीच का मैक्सिमम स्टैटिक फ्रिक्शन लग सकता है. देखो फ्रिक्शन लगेगा कैसे. जैसे ही मैं फोर्स लगाऊंगा द फ्रिक्शन विल एक्ट इन दिस डायरेक्शन एंड हियर द फ्रिक्शन विल एक्ट इन दिस डायरेक्शन. अगर आप इसको समझे तो आप समझ सकते हैं जैसे जैसे आप इस फोर्स को बढ़ा रहे होगे its tendency to move in the forward direction will increase. So this friction that is acting, if it is static, then it will also increase. It will also increase till its maximum value. Till its maximum value. एक maximum value तो क्या बढ़ता रहेगा. Now when it gets maximum at some instant, एक maximum value तक it will rise. जब ये maximum हो जाएगा, जब तक ये static लग रहा है, there is no slipping between them. And when there is no slipping between them, both the blocks will move together. Both the blocks will move together. But when it will not static, जब हम फोर्स को और बढ़ाएंगे तो स्टैटिक फ्रिक्शन एक औकात से ज्यादा बढ़ नहीं पाएगा. If the static friction is not increasing more than that, तो ये दोनों आगे इकट्ठे चल नहीं पाएंगे उस फोर्स के बाद. राइट? इस चीज को देखो हम कैसे समझ सकते हैं. मान लो इफ वो दोनों इकट्ठे चलते हैं, मान लो बोथ विल मूव टुगेदर. अगर टुगेदर चलते हैं तो 8 kg द फ्रिक्शन विल गेट द इंटरनल फोर्स एंड द फोर्स F इज एक्टिंग. तो यू कैन से व्हाट इज एक्सेलरेशन, कॉमन एक्सेलरेशन. द कॉमन एक्सेलरेशन इज that is F by 8 kg, right? If we just make a free body diagram of the 5 kg, now it has a tendency to move in forward direction. Friction is acting in this direction, Fs. Let's know the Fs value is mu s max into mg into Fn. And what is the Fn between them? Normal reaction is 3g. Into 3g, that is acting on it. So you can say the acceleration corresponding to that, A, that is mu s into 3g by 8 by 5. That is the acceleration of the lower block corresponding to the maximum value of the static friction. Maximum value of the static friction. And you can easily judge if the maximum value of the acceleration या this acceleration जो हमारे पास यहाँ पर acceleration है, अगर ये acceleration इससे कम है तो both will move together. If common acceleration is less than the acceleration A, then both blocks will move together. राइट अगर उसकी एक्सेलरेशन उससे कम है तो दोनों ब्लॉक्स इकट्ठे मूव करेंगे. बोथ ब्लॉक्स विल मूव टुगेदर इन दैट केस. राइट इफ AC less than A, then both will move separately. Is it clear? तो that is the case कि वो दोनों इकट्ठे चलेंगे, अलग अलग चलेंगे. We can check it with the help of acceleration and the common acceleration. Here the Fn will be acting that I have shown below as also कि यहाँ पर Fn कितना है? The normal reaction between 5 kg and 3 kg, it is 8 kg. Is it clear to all of you? लिखेंगे इसको प्लीज.